Next, I'd like to welcome up a personal friend, Will Mapp, who is the Executive Vice President for a company called Servergy. Servergy is one of the founding or early members of the Open Power Initiative, and he represents a company that's doing a lot of great work inside of Open Compute with a lot of interesting green tech patents that are completely architecturally agnostic. So please help me welcome Will Mapp.
Thank you very much. Very excited to be here. Spent a lot of time traveling around the world with Cole and the rest of the Open Compute group. It's been one of the most enjoyable experiences of my life. And one of the things that I've really seen traveling around the world is the incredible amount of information that we see growing, the data deluge around the world growing. And how do we address all this in the market and the infrastructure going forward, and really looking at the innovation and the data center required to support that. So we've seen a lot of these stats around the zettabyte age and what that really means. And there's a quote that I heard by Louis L'Amour that says that over time, information will grow in volume and variety and hopefully value. So we've normally heard the 3 V's around big data, volume, variety, and velocity, but there's a 4th V that's really driving all of this globally. It's value. The value of information. It's our drive to gain more information about our lives and how we live and why we do what we do. And so as we look at the cost of our ever-ending search for knowledge and the value of that information, we need to really look at how we fundamentally go forward in supporting that search in the future. So right now, if you look at the cost of information, of housing, the age of the zettabyte, right now the data center is consuming around 10% of the world's energy globally and growing rapidly. Also, from the cooling space, in around a 2-day period of time, the average data center can use as much as an Olympic-sized swimming pool of water just for cooling a data center. So we're talking about a tremendous impact globally. If you think about fundamentally about the power, it takes a lot of water to also make power. You think about a lot of regions who are already having drought issues, having to make some very huge decisions around how they're going to be balancing that. You think about the summertime, even through the wintertime, we see a lot of these electrical concerns. This also fundamentally comes back to water as well. Also into space. There's currently over around 400 million square feet of data centers globally and growing very rapidly. Right now, data center real estate is one of the highest forms of real estate investment globally. And right now, people are trying to figure out how they can get a better return on their investment for real estate. And so it's a really huge opportunity and issue that we can address into each one of these. If we look at fundamentally and the cascade effect, when we start looking at where we can innovate and where those decisions trickle down into the rest of the infrastructure, we look at the server, early on. And right now, as it is, around 1 watt of power saved at the server saves close to 3 watts at the data center level. And so when you look at an average data center consuming around 15 megawatts of power, and you look at the tiers of having the redundancy power to go along with that, a watt makes a huge difference, and so does the 3 watts of potential savings that we have to impact those data centers. There's a couple different ways people are approaching innovation around power, cooling, and space, fundamentally trying to figure out how to solve some of these issues early on in the architecture and design of these platforms. A lot of what we've been seeing in a lot of different areas is taking a processor approach, an architecture focus to how we go about designing these platforms. And we at Servergy see a real trend and real focus to really solving these problems in a very different way fundamentally than just trying to throw an architecture at an issue. If you have a company who's invested millions of dollars into x86 code base, all the personnel and resources around that to drive and support that model, trying to push another architecture on that doesn't necessarily make a lot of sense. Some people are willing to do that, but as a whole, people want to be able to better gain an ROI on the investment they've already made. And so really being solution-minded, figuring out what is the problem they're trying to solve. Is it power? Is it space? Is it cooling? You look at Tokyo, there's huge seismic implications when you're building data centers vertically. So weight is a huge implication. And so we really need to be able to step back and not just toss an architecture at it and say, one size fits all, you can have any color you want as long as it's black, but really step back and say, what is the problem you're trying to solve? What's the result you're trying to get? And be able to work the problem backwards from there. So if we look at all the different types of workloads in the data center, they're very vast and they have very huge implications on the architectures, not only at a processor level, but at a system level, the requirements that you would look at when you go on to designing these platforms. And so this is where we need to be starting to have the initial conversation before we even get into architecture or platform design. It's really around looking at the workload. And then from there, more realistically, we're going to probably take a holistic approach, because a lot of times you have these same workloads even in the same data center in a wide variety. So it's really going to have to be a holistic approach to how we approach these workloads and be sensitive to the investments people have made around their current infrastructure. If we look at even Hadoop as a workload, we can see very quickly on the characteristics of the workloads. Some are very I/O intensive, some are I/O and processor intensive, and some are just straight processor intensive. And so you can see very quickly that it's not a one-size-fit-all in just this specific workload itself. And so this is where we need to be able to take a holistic approach and say, okay, we need to be solution-minded around this and figure out what's going to give the best overall performance per watt, ROI on the investment that somebody would need to be able to focus on building a better data center around the solutions that they have. And this is where we come back to saying, being solution-minded. There's a wide variety of tools and resources out there that if we step back from just looking at the overall server itself, but thinking as the architectures as you would a resistor or a capacitor, we're no longer arguing about the different components at a board level much more than the architectures at this point. And so we really need to be able to change that level of abstraction of the conversation to now really being solution-focused and solution-minded. One of the things that we see around this growth of information, all the stats that we see around the zettabyte age, the data deluge, big data, cloud computing, whichever terminology you want to use, this is all focusing on an I/O-intensive world. Yes, there are still compute-intensive workloads out there, but nowhere close to the amount of I/O-intensive workloads that we see, managing a tremendous amount of streams of data globally, and the connections that are required to handle this data. And so if we look at where SoCs are growing, they're growing really into more communication-style SoCs, really having more network offload built in, having all kinds of other offload engines for security and other types of functions, onboard fabric controllers. I'll go in to talk to you about one of the ones that we have in the communications SoC that we're using. Also ASIC-style implementations, not just of the SoC itself, but of the overall system. I had a real pleasure to be able to go and take a visit of one of the Facebook data centers. I got to say, it's a real work of art. It's amazing to see a purpose-built data center from the ground up. It was mind-blowing, a real piece of art. And so as we go forward, it's not just about the ASIC of the component, it's also about a purpose-built solution, a purpose-built data center. If we're going to be able to sustain the long-term growth that we see, the explosion of infrastructure, we're going to have to be able to think really clearly purpose-built, thinking very clearly from not just from the server, but the solution going forward. What was the purpose and the design of building this infrastructure? That's how we're going to get the better ROI out of our equipment and really allow the equipment to be able to sustain the long-term use that we're really expecting out of that investment of that hardware. And so if we look about other ways that people are trying to gain density, optimize performance, take a disaggregated and modular approach, we're very excited about what Facebook's doing with Group Hug, and see some huge opportunities, and with others that are out there now taking a density-optimized approach to platforms. See some real opportunities there. But one of the things that when we started looking at some of the advantages and limitations of some of the density-optimized platforms and being able to really go back to that workload slide is being able to support scale up, scale out, and scale with quantity of cores. And so what Servergy did, we went back to the drawing board, and when you look at some of the brawnier processors, brawnier SoCs out there, to be able to really support these SerDes lanes, the lanes coming off these brawnier processors, we really need to be able to have more connectivity going to the bottom plane or the back plane itself. So what we did is we moved to 2 Gen 3x16 connections on these cards. And what that allows us to do with this card is to be able to really offer both scale up and scale out. So if we want to throw a Xeon on here, a Power 8, a very large communications SoC, or even a tremendous amount of memory, it gives a lot of options for the platform itself, and we really see it as continuing to add to the group hug roadmap, and being able to offer a tremendous amount of value to the investment that's already been made in group hug, and this being addition to add to that. And I'd like to take a second to show you the platform. I have one of the cards right here. And so the card that we're using right here is a free-scale semiconductor communications chip. It's called the T4240. One of the exciting things about this chip here is this chip has 40 gigabits of I/O throughput. It has rapid I/O natively built in. The controller is a high bandwidth interconnect. 96 gigs of RAM. A tremendous amount of offload capability, and doing all this for around 100 watts of power. We, right now, believe we can get around 16 of these in a 4-use space in a very modular drawer type of fashion in an open compute rack. And so we're very excited about being able to put a Power 8, x86 chips on here as well as ARM, and being able to really have a scale-up, scale-out modular platform that will allow us to be able to address multiple workloads, multiple environments, but really being able to standardize on a platform that's very modular and capable of a wide variety of things. Also, you can imagine the very dense storage applications and implications of a card this size and a density of that quantity. It's really amazing. One other thing I'd like to mention about this is if you look at some of the traditional supercomputing and HPC type of platform architectures, they're also set up very modular in this density optimized platform. And so there's a lot of opportunities going forward of what would an open compute, supercompute platform look like, or an HPC platform look like. Obviously, between power architecture and the Intel base, there's a lot of implications on what we could do, really world's first type of platforms here. Again, looking forward towards the solution roadmap Servergy's laying out. We're very excited about engaging with the community to be able to provide against multiple architectures, multiple fabrics, really standardizing on the platform, leveraging a lot of the standards that Facebook's already shown into the group hug platform that allow us to be able to combine both of those types of density optimized platforms together, and really being able to acknowledge we have a solid platform to be able to step back and look at the workload and build around that. Again, when it comes to promotion of the platform itself, if somebody says, well, is it x86, is it Power, is it ARM? Again, we want to step back and say, look, benchmarking is required. We want to step back and say, what is performing the best? Because depending on what the customer wants and what the customer needs, where they're willing to give and take, on that balance, we could go a lot of different ways. But again, it's about providing the best performance possible to help the customer get a better ROI. Last little point I wanted to mention was in the spirit of collaboration around open compute. It's just an amazing foundation. Never have I seen such innovation and collaboration occur at some of these engineering summits, having thermal, software, hardware, end users, investors, all in the same room talking over problems, being able to rapidly work through issues and conversations. It's just one of the most exciting experiences that you could ever be a part of. So I wanted to leave with one of these last quotes from Charles Darwin. It says, in the long history of humankind, and animal kind too, those who learn to collaborate and improvise most effectively have prevailed. And so I think it's at a very exciting time of collaboration. We definitely have the tools, the resources, the structure here at the foundation. I think it's a very exciting time for us to be a part of this growth and some of these issues and challenges we see going forward. And one of the last slides I'll leave you with here is about formation is the key to effective collaboration. And that's what's really exciting here. It's not just collaboration for the collaboration's sake, but there's true formation here, true structure, true discipline, you know, to the type of collaborative approach that we're working on here in the foundation. And it's really making a difference, as we can see, and has some real implications globally. And so Servergy is very excited and proud to be a platinum sponsor this year's event and be part of the community, and I look forward to spending time with each and every one of you over the year and working in a very collaborative manner on some of these large issues. So thank you so much for your time, and it was a pleasure to come out here and speak with you.